Software quality assurance, or SQA, is paramount in modern software development. It acts as a safeguard, ensuring that software products meet predetermined quality standards and customer expectations. SQA is an ongoing process interwoven throughout the entire software development lifecycle. From the initial requirements gathering to final deployment, SQA activities are crucial in identifying and rectifying defects early on. SQA professionals play a pivotal role in mitigating risks associated with software failures, security breaches, and performance issues. Through rigorous testing and meticulous analysis, SQA teams ensure that software products are reliable, secure, and perform optimally. In today's competitive landscape, where user satisfaction and brand reputation are paramount, SQA is an indispensable investment. The consequences of neglecting SQA can be dire, leading to financial losses, legal liabilities, and damage to brand image. Poor software quality can result in frustrated users, decreased productivity, and a loss of competitive edge. By investing in robust SQA processes and skilled professionals, organizations can significantly reduce the likelihood of such negative outcomes. Ultimately, SQA is about building trust with users and delivering software that meets their needs and expectations. By embracing a proactive and comprehensive approach to SQA, organizations can mitigate risks, enhance user satisfaction, and gain a competitive advantage. The investment in SQA is an investment in the success and sustainability of any software-driven endeavor. Test execution is where the meticulous planning of SQA transforms into action. It involves systematically running the designed test cases to evaluate the software's behavior and adherence to requirements. This phase is crucial for uncovering defects, validating functionality, and assessing the software's readiness for release. Effective test execution demands a structured approach, ensuring that all test cases are executed, results are accurately documented, and any deviations from expected behavior are reported promptly. The process typically begins with the creation of a test execution plan, outlining specific test cases, order of execution, environment setup, and team roles. Testers meticulously execute each test case, documenting results and reporting discrepancies as defects. Test execution encompasses various types of testing, each focusing on different aspects of the software. Functional testing ensures the software functions as intended, while usability testing evaluates ease of use. Compatibility testing verifies the software's compatibility with different systems, and security testing identifies vulnerabilities. These testing types provide a comprehensive evaluation of the software's quality and readiness for deployment. Test execution subjects the software to rigorous scrutiny, uncovering hidden defects and ensuring adherence to quality standards. Automated testing involves using software tools to execute test cases, enhancing efficiency and test coverage. Automated tests can be executed significantly faster than manual tests, allowing for quicker feedback cycles and faster identification of defects. Automation enables the execution of a larger number of test cases, covering a broader range of scenarios and potential user interactions. Automated tests execute the same steps with precision every time, eliminating the potential for human error. This consistency ensures that defects are identified and reported consistently, reducing the likelihood of issues slipping through the cracks. Automated tests can be easily repeated, making it simple to verify fixes and ensure that previously resolved defects do not resurface. While automated testing offers significant advantages, it's not a complete replacement for manual testing. Certain aspects of software testing, such as usability and user experience, require human judgment and intuition. A balanced approach that combines automated and manual testing is crucial for achieving optimal software quality. Automated testing is a powerful tool for repetitive tasks, regression testing, and performance testing, enhancing the overall SQA process. Manual testing remains a cornerstone of the SQA process, involving the meticulous execution of test cases by human testers. While automated testing excels in repetitive tasks, manual testing shines in scenarios that demand human perception, creativity, and critical thinking. Manual testing uncovers usability issues and assesses the software's overall user experience. Human testers provide invaluable feedback on the software's intuitiveness, ease of navigation, and user-friendliness. Automated tests often fall short in capturing the nuances of human interaction and perception. Manual testing allows for exploratory testing, where testers delve into the software without predefined test cases, uncovering hidden defects. This ad hoc approach often unveils critical issues that might not be caught through scripted automated tests. Manual testing adds a layer of human intelligence and adaptability to the SQA process. Despite its strengths, manual testing can be time-consuming and subjective, requiring well-defined test cases and experienced testers. A robust process for documenting and analyzing test results is crucial for effective manual testing. Performance testing evaluates the speed, scalability, and stability of software applications under various conditions. It aims to identify bottlenecks, measure response times, and ensure that the software can handle the expected workload without compromising performance. In today's digital landscape, where users expect lightning-fast responses, performance testing is paramount for ensuring user satisfaction. Performance testing encompasses various types of tests, each designed to assess different aspects of software performance. Load testing evaluates the software's behavior under normal and peak load conditions, simulating a large number of users. Stress testing pushes the software beyond its limits to determine its breaking point and assess its resilience. Endurance testing evaluates the software's stability over extended periods of operation. The insights gained from performance testing are invaluable for optimizing software performance. By identifying bottlenecks and areas of improvement, developers can enhance the software's speed, scalability, and reliability. Performance testing is crucial for web applications, mobile apps, and any software that handles large volumes of data or user traffic. Reporting transforms raw test data into meaningful insights that drive decision-making and improve software quality. Effective SQA reporting goes beyond listing defects. It provides a comprehensive overview of the testing process, highlighting key metrics, trends, and areas of concern. These reports serve as a vital communication tool, keeping stakeholders informed about the software's quality status. SQA reports typically include a variety of information, tailored to the specific audience and purpose. Test summary reports provide a high-level overview of the testing activities, including the number of test cases executed and defects found. Defect reports delve into the details of each defect, providing information on severity, priority, and steps to reproduce. Trend analysis reports track defect trends over time, identifying areas of improvement and potential risks. Regular status reports keep the team informed of the testing progress, while detailed reports might be generated at key milestones. Effective SQA reports are clear, concise, accurate, timely, and actionable. By providing clear and insightful reports, SQA teams empower stakeholders to make informed decisions and prioritize issues. Defect tracking is a systematic process for identifying, documenting, tracking, and resolving defects found during software testing. It involves meticulously recording details about each defect, including severity, priority, steps to reproduce, and the environment where it occurred. Effective defect tracking ensures that defects are addressed promptly and efficiently, preventing them from resurfacing in later stages of development. Defect tracking typically involves the use of specialized software tools known as defect tracking systems or bug trackers. These tools provide a centralized repository for all defect-related information, enabling teams to log new defects, assign them to developers, and track their progress. By streamlining the defect management process, defect tracking systems enhance collaboration between testers, developers, and project managers. The benefits of effective defect tracking extend beyond simply fixing bugs. By analyzing defect trends and patterns, teams can identify areas of the codebase prone to errors and improve coding practices. Defect tracking data provides valuable insights into the overall quality of the software. By implementing robust defect tracking processes, organizations can streamline defect management and improve the overall quality and reliability of their software products. Metrics and analysis provide a quantitative basis for assessing software quality and tracking progress over time. By collecting and analyzing relevant metrics, SQA teams can gain valuable insights into the effectiveness of their testing efforts. Metrics provide a clear and objective way to measure progress, communicate results to stakeholders, and demonstrate the value of SQA activities. SQA metrics encompass a wide range of data points, each providing insights into different aspects of software quality. Commonly used metrics include defect density, test coverage, and defect resolution time. By monitoring these metrics over time, teams can identify trends and continuously improve their testing practices. The analysis of SQA metrics involves more than just collecting and reporting numbers. Effective analysis requires understanding the context, identifying patterns, and translating data into actionable insights. Comparing current metrics to historical data, industry benchmarks, and project goals helps identify areas for improvement. By collecting, analyzing, and acting upon relevant metrics, organizations can gain a clear understanding of their software's quality and make data-driven decisions. Documentation plays a crucial role in SQA, serving as a repository of knowledge and a guide for future reference. Thorough SQA documentation captures the essence of the testing process, from initial planning to final test reports. Well-documented test plans, test cases, and test results provide a roadmap for future testing cycles. Comprehensive documentation serves as a valuable training resource for new team members. SQA documentation is essential for compliance with industry regulations and standards. Many industries require organizations to maintain detailed records of their testing activities. Comprehensive SQA documentation provides the necessary evidence to demonstrate compliance and mitigate potential risks. SQA documentation ensures knowledge transfer, process improvement, and compliance with industry standards. By embracing thorough documentation, organizations can enhance the effectiveness of their SQA efforts. Documentation is an integral part of the SQA process, ensuring high-quality software that meets user and stakeholder needs. Software quality assurance, SQA, is the bedrock upon which robust and reliable software is built. It's a continuous process, a mindset, a commitment to delivering excellence to end users. Effective SQA is a combination of skilled professionals, well-defined processes, and the right tools working in unison. From meticulous test planning and execution to detailed reporting and insightful analysis, each stage of SQA contributes to high-quality software. Understanding the nuances of test execution, the power of automation, and the value of human insight in manual testing are key. Recognizing the significance of performance testing in our fast-paced digital world is paramount. Harnessing the power of reporting, defect tracking, and metrics analysis allows us to glean actionable insights. These insights drive continuous improvement, leading to more robust, reliable, and user-friendly software. By embracing the principles and best practices of SQA, we pave the way for software that exceeds expectations. This is the true hallmark of effective SQA, driving software excellence one step at a time.